Next up, we have the last talk of this track, and it's machine learning with the Google Cloud Platform, where Mr. Tiago Henriques, the head of AI/ML technology practice at Google Cloud EMEA, will present it to us. Welcome to the stage.
Hello. Hi, good morning. I'm Tiago. I work at Google Cloud. With my team, we help customers to adopt different solutions of AI machine learning solutions. And I'm here just to talk a little bit today about several technical details. Pleasure to be here. I'm conscious that I'm standing between you and lunch, so I hope I managed to get your attention until there. It's my first time in Serbia, so really enjoying it, and hopefully we'll come back next year to present even more on this side. So before we get into a lot of the possibilities of doing AI machine learning in the cloud with the Google Cloud Platform, as you for sure are aware, Google has been doing AI for a very, very long time. You have a set of different examples in this slide around how we apply different machine learning and AI techniques. And I think one of the things important to understand is how Google applies that across different business areas, but at a very, very large scale. And as you can imagine, that touches billions of end users every day, also companies. So that tells you a little bit the level of maturity and experience in that space. Another point that I think is quite important to also think about is the research that Google, as a specific division for that, puts out every year. So there's more than 1,000 papers that go every year out that also bring a lot of innovations on algorithms and other capabilities that we capitalize and use in our platform. So when we talk about Google Cloud Platform, that's of course the way to use public cloud in Google. There's a lot of services there. But if you look specifically around AI machine learning, I think once more it's very important to understand that there is Google research. There's also Google Brain that is a bit more looking ahead. There is DeepMind, very famous for AlphaGo. A few years ago, it was mentioned also yesterday. We actually have a very nice blog, Google AI, that literally every week there is 2 or 3 very nice posts about some cutting-edge things happening there. And looking at our strategy, of course, is to bring you managed services that allow you to be more efficient as a data scientist, as a machine learning engineer, but also keeping in mind that Google is an open source company, right? I think you all know where TensorFlow comes from, Kubeflow, Kubernetes, a lot of what is used in production with open source at very large scale. We keep contributing back, but it's very important for us that we manage the capability to keep adding other open source capabilities to companies using that. So if you look a little bit more specific in AI capabilities on Google Cloud, I think it's very important to understand that we really try to address a very large segment of end users. Okay. First, it's really about on the mission to democratize AI. So that means that eventually every person that interacts with those systems can consume it, sometimes even without know that it's AI. So that's what you have calling out of the box. So there is a lot of no-code, low-code, pre-trained models that you can consume as an API. Think about them as a commodity. You like them, you use. It's not fitting your problem. That's good. Just use something else. Then there is a very interesting space, which is around using AutoML. So that's also no-code. You just start, of course, with the data set. You say what you're training for, and it tries to use a lot of algorithms and see what performs better. And finally, and that's what I'm really here to talk about today, is about advanced users. So how many data scientists do we have in this room? Please? Okay, that's 80%. ML engineers? Okay, data engineers? Okay, 20%. Oh, 15%. Managers? I'm one of them. Okay, very good. Business people? Okay, now I have an idea. So today we'll talk about our capabilities targeting professional data scientists, so 80% of this room. Before I dig into a lot of details, I just want to give you a big picture of everything that Google is doing on this space. So if you look at the portfolio of AI machines and machine learning services on Google Cloud, it's extremely extensive. I will not bother to kill you with every single one of them. There's more than 40 of them. But I think it's important to understand that some of them have been grouped together, if you want, to be more packaged solutions. That's the ones that you have in green. Which I'm just going to brief you just for your information. There's one of them is called Contact Center AI. So of course it targets customer experience. You can think about conversational, chatbots, virtual agents, voice bots. So a way to interact with those agents, where we bring a lot of AI capabilities bringing, of course, dialog flow to create those quite powerful conversations. There is document AI that basically allows you to extract a lot of information from documents. Think about, for example, ID card, think about invoice, any kind of documents. Organizations have millions of documents, so you can extract very easily. Of course, it's not just OCR, there is a lot of more advanced, and you can also customize some of those models. Then a big area of focus is also around personalization. That's called Discovery AI. So you're able to create quite sophisticated recommendations for retail on online businesses. And also search. So if you have a very large catalog of products, if you're a retailer, you can also index those and get quite advanced search, like saying, I want to get shoes for running, and it's going to understand semantically what you're saying. Finally, there is a specific solution for healthcare that understands a lot of the formats behind the scenes. There is a lot of formats there. It allows you to do NLP, bioimaging, and a lot of other use cases. But all of them lie on a foundational component, which is called Vertex AI, and that's what we're going to talk about today, which is really the managed service for professional data scientists to be able to train models, deploy them, consume, and hopefully get faster time to value. Just to give you an idea where Vertex AI is going through before getting some of the technical details, first it's very important to understand it's not just about machine learning, right? As you all know, it starts with the data. You need to have the right data until you start to really create the models. So our vision is really to create a unified data platform that allows you, of course, to do analytics, ingest the data, prepare it, and then really start the machine learning process. So that's one of the areas that we've been investing. Second one, I'll show you a few examples, is around the machine learning operations. So it's more taking things automatically in production. That's one of the most important things to do when you're doing machine learning models. Then we see a big trend on customers going after large model training. So that's why you require on-demand, large infrastructure, GPUs. TPUs are a very specialized hardware that Google created some years ago. That's very interesting for those cases. And also keep bringing state-of-the-art capabilities, especially in terms of algorithms. As I mentioned, some of those are part of the research. So Vertex is very mature, an interesting platform to do anything you can do on the data science expected workflow. I will not talk about every single component today because unfortunately we don't have enough time, but just think about from experimental perspective, training, deployment, and then there's a set of different capabilities that I'll be showing you with an example this morning. Once more, if you put yourself on your normal day-to-day shoes, for the end-to-end data science flow, of course, you start with ingesting the data, doing analysis. Of course, it's important, for example, to be able to register a data set, so I know where is the data set pointing to the data source. I do all my transformation. I'm going to show you a lot of examples how that part can be important for features. I train it. I have different ways to train. I can train with my own code. I can bring, of course, any open source library, or can I also use automated ML to try to train for me and see what performance I get. Then, of course, I want to have models, so registering the model is important, evaluating those models' performance, and then, of course, integrating that with the business process, which is deploying them and consume from an application, or just put the results of the predictions back where it makes sense. So today, to highlight you some of the Vertex AI capabilities, I'm just bringing an example. That example has actually been part of this conference. So we had a hands-on workshop on Tuesday with some of my colleagues that created this content that you see on this slide. And the use case here is quite interesting because it's about finding fraud into financial transactions, so credit card, for example. That's top of mind for a lot of financial companies. But it's also not just the most trivial one, right? Because you have a lot of data coming in, and you have very few seconds to make a decision if a transaction is fraudulent or not, okay? I'm cautious you see a lot of boxes there. I'm not going to kill you with all of them, but just the most important point on this example to show you some of the capabilities of the Vertex AI is just think about that you have a lot of historical transactions, so millions and millions of transactions in a data warehouse, in this case in BigQuery. And then on real time, people are making transactions and we need to ingest them. In this case, we are using a pub/sub technology just to put them and of course integrate with everything that we have here. The red arrows is what I'm going to show you in more detail today, which is, of course, analyzing that data, creating features, feature engineering, and then how do we train and use that into a pipeline. Okay, we start, of course, with the basics. Most of the time is really iterative, EDA, exploratory data analysis. That's, I guess, where most of you spend a lot of time. Yes, good to check that. So in Vertex, you have a very nice capability called Workbench. I'll just show you a short video. Hopefully, the video will be with me. So basically, you can provision a notebook, a managed one, an instance, where you as a data scientist can just connect have your notebook. The case you're seeing here is actually, I'm connecting to the BigQuery. I'm just checking, in this case, the transactions amount per account. And I'm just running some more code until I just do some final analysis. There should be a plot there. So typically, the beginning of your job, connect to that, execute yourself interactively, and don't worry about that. So just in a few minutes, you can spin up a workbench and start to work. That's quite important. You can, of course, install your packages, but it's a managed service. Now, what I really want to show you today is some of the features on Vertex that I think they are quite advanced and can bring you a lot more value in case you're not using them or you're looking for improving some of your end-to-end workflow. I think it's a bit cutted. I'm not sure if it's just a slide. Let's see. So I'll talk about feature store, top pipelines, explainability. That's something very top of mind these days. And now we are also bringing some quite recent algorithms there. So feature store, again, question. Otherwise, you get a sleep or you go for lunch. How many of you use a feature store in your day-to-day job? One? Just one? OK, interesting. How many of you think you don't need it and it's boring? How many of you don't know what is a feature store? OK, there's one that think it's boring. Good. I used to get that from data scientists often. Anyone doesn't know what is a feature store? OK, few people. Don't be shy. It's completely OK. So feature store is a very simple concept. In my conversations with a lot of customers in data science teams, I understand that some of them either don't use it yet, or some of them still want really to understand why that can improve their workflow. Honestly, I think it's one of the most important things that you need to do when you do real professional data science. The concept is very simple. You have, let's say, a specific store capability to put your features. That's just the idea. Because most of your job is just getting good features, prepare them, and start to train the model, no? OK. So basically, you connect to data sources. You bring the features from the data source. You transform them, and you persist them. Another additional advantage is it's not just about you. It's about your team, and maybe your team next month, or another team in your organization. So having a feature store also allows you to have a centralized place where people in your organization can see what features already exist, where maybe some data scientists spend hours on preparing them and just start to consume them in your workflows. Once more, collaboration and cross-division use cases is quite important. That's one reason why I think feature store is quite important. So I'm showing you a very short video here. In this case, what we're doing is we are using a batch approach. So it's, let's say, one time. We are connecting to BigQuery. Running a SQL query that you're going to see there in a second. Getting some of the features, as you can see by the names, transaction, customer ID. It goes a bit fast. I'm doing a few counts and a few averages. So those are already new features that I'm creating that doesn't exist in the data set itself. So I'm doing some, in this case, I'm doing data preparation with a SQL query in the data warehouse. And then the other thing I'm doing is saying, OK, run a query. Those are my features. As you can see, there's a lot of new features there. I'm cautious it goes a bit fast, but we don't have much time. And then after that, I'm just connecting to the feature store, in this case with codes, and saying I want to persist that there. So that's one time. That's why it's called a batch. Okay. So just with this, you already have your features generated. Of course, you can do more complex things and persisted. And as you can see behind the scenes, is running a job to ingest that into the feature store, so that stays there and can be used, of course, later by you or some of your colleagues in your data science process. That's already a lot of value on the batch side. Now, for more advanced use cases, we need streaming. And that's, of course, in general industry trend. We need to go to real time or close to real time, depends what it matters in some context. So we have that actually quite recently, and I'll say quite unique capability around using same concept of feature store, but in real time. I'll show you a little bit a video. So in this case, I have, like I told you, the pub sub. I'm running a real-time stream processing job, in this case with Apache Beam. So I'm getting all the transactions, and I'm basically being able to either query the model in real time, as we'll see a graph in a second, but also consume those features in real time, and also prepare new features if I want in real time, which is pretty common on more advanced recommender systems, that you really need to create new features quickly and retrain the model also quickly. Okay, so that's pretty much the big idea here. In this case, we are doing a lot more code, but by the end of the day, we are connecting to the data flow. That's the managed service for Beam, and you'll see here. There is a graph that explains what's happening behind the scenes. So there's a lot of processes happening, and that's when the job is running. So you have a lot of messages per second going to the real-time stream, persisting the new features into the feature feature store in real time, new features, and also doing the model inference. Okay, so that's one of, I think, most interesting use cases for feature store, is to take it to the next level of real time. Okay, hopefully you'll check or try feature stores in the future. I think it can add a lot of value to data science into your workflow. How many of you write machine learning pipelines to take them into production? Okay, that's 30%. How many of you hate to take care about that? Okay, that's fair as well. Okay, so pipelines. Sorry, before pipelines, we need to train. So in Vertex, of course, you can train in a notebook, like I just showed you before, but you don't need to be in front of it every time, right? So the concept is you just, once your model is good enough and you finish your ADA, what you can do, you can just submit a job. In this case, I'm just showing it from a notebook for simplicity. You can be doing that from your laptop, saying I want to submit a training job into Vertex, right? And it can be, of course, scheduled and automating. Think about model retraining every week, for example. One thing to notice here is that behind the scenes it uses Docker and the container. So you can completely customize and specify anything you want. We give you a base image, but if you want to do a lot more advanced or bring your own libraries and so on, that's also possible. So in the end, what I was doing is submitting a job. Now I'm going to go to the UI, and I go to the training section. And you see there is a job running. And the last step, very important, is once that job finishes, the last few lines of that code, what it does is persists that model. And that's quite important when we want to automate things. So basically, we're just saying, okay, I finished this model, I want to persist it. That's what you see in this last step. Okay, so taking models into production. That's the most important thing, because models by itself, they have no value if they are not used with the business process. So that should be always. Staying in the laptops without being consumed, no business value, okay? So there is, of course, this big topic around MLOps. A lot of companies trying to do it at different ways, but always think about, when we talk about MLOps, you should always think about not the model that you created or the models that your team created, but really about going at scale. Because we all know that companies, they will, over the next few years, they're going to deploy hundreds and thousands of models into production, even if they might not doing it that day. So you always need to think about scale, and for getting scale, for machine learning, you need to automate. Of course, machine learning is a bit more complex than software by itself, because there is data changes, model loses performance, so we need to think twice how do we implement, let's say, traditional DevOps approaches for software, but for a machine learning world where data changes. So here, what you have is, of course, the typical flow, validate data, prepare data, train, evaluate, and so on. All of those steps can be put into a pipeline, okay? And here, when I talk about a pipeline, can be a set of pieces, can be different code and so on. And of course, in each step, I could be calling the service I need, like training the model, deploying the model. Those are the examples. So how do you do it practically? So you do it with code. That's good. You can actually use TFX, TensorFlow, or Kubeflow. We support both of them. So once more, if you have existing open source, you can just bring it and we create a pipeline for you. And one of the interesting things is, think about every single step of your pipeline that can be decoupled and separate, which means if you want to rerun your full pipeline, if you didn't change all of the steps, you can just rerun the ones that make sense. That's actually quite agile, so you don't need to wait, and you don't need to spend so much cost there. So I have a short video, same use case, Fraud Finder, which this one is a bit longer. So what I'm doing is just with code, I'm actually defining components, and you're going to understand in a second visually why. But just think about every single step of the pipeline. I'm just defining it with code, with Python, and saying which one I'm going to train, how is the evaluation. So that's the first point. Then I'm just saying, okay, this is going to be a pipeline that will be compiled to be run, which can be run now, or can be triggered externally to be run. Now, what you have is actually a very nice visual representation of that, which is quite important when people want to check what's behind the scenes, and also if you think about regulator and so on, explain what was created and how, that's quite important. Then you're just looking at the model deployment. As you can see, there's a lot of assets. You can have if conditions, say if the threshold of MSI is higher than 80%, then we deploy the model. Okay, think about that, because that's the way we automate. And of course, as you can see, we generate a lot of assets, which can be the model registry, the metadata related with that. So in this case, we just finished to run the job, and the last step we did is deploy the model. In this case, deploying a model means creating an API, an endpoint, which can be consumed. So that's an example of a pipeline, in this case for the front finder. Behind the scenes, we leverage a lot more capabilities that are important that was in the middle of that code. First one is, of course, every time you're training a model, you should track your experience because you're generating new runs, once more, in your laptop, in Vertex training, and so on. So you're generating new metrics, so you should always know if that improved the model or not. So that's one way that you can do, just with a line of code, you're just persisting the metrics you're generating, and can be custom metrics depending on the open source library that you're using. Second thing that is quite important here is, of course, the metadata that is generated behind it. So we have the model, we generate assets. Of course, the model itself is a binary, if you want, or a set of coefficients and residuals, but we want to track that. But more importantly, we want to have the lineage of what happened end-to-end to the process. So I want to go to the level of detail with this metadata to know who trained the model, when, with which version of TensorFlow or PyTorch, which data it was used at that time. So I have the full traceability, and once more, sometimes I really need to justify even to regulators what was behind the scenes. So that's something that you achieve with it. Another last point that is important when you want to automate things for taking in production with MLOps is really about monitoring the model, because you all know better than me, after you train a model, 5 minutes, 1 hour, the model performance will decay over time, right? So it's not just taking models into production. If you don't monitor how they are performing, then you can have a big business issue. So what we do is we also have this capability here where you can constantly or easily checking your model performance and also your data origin. Because if the data origin changes, you start to get some skewness. Of course, you know what will happen. The model will change the behavior or the performance. So that's a quite important one. And when we talk about MLOps, you need to put all of that together. OK. 2 more things to go. Explainability. I'll be brief on this one. If you want to talk offline or have any questions, please reach out. This is, of course, top of mind for everyone. It's not just about creating models, putting them in production efficiently, automatically, as I mentioned to you, but more and more people ask, OK, great, your model. Can you explain why and how? So that's the component. And there was a lot of interesting talks here around explainability. So, of course, it varies a lot to the kind of problem that you're asking. If we simplify it a little bit, if you're looking at images, text, or tabular, you ask why? Different way to explain the why. What you see in the left is an example that, of course, we look at the pixels. In this case, we are predicting if it's a husky. That's the class. In the other one, we are predicting the sentiment. So which words in the sentiment were affecting to say yes or no. And then on tabular data, pretty common. You want to see the feature importance for that, but also going to the level of the individual and say why Tiago got rejected in a credit card and which features made that decision. So we have the global view and the specific view. There's a lot of moving parts in that space, so definitely keep an eye there. I would say the 2 more famous ones are probably Lime and Chap. Anyone used Lime and Chap in the past? OK, a few of you. OK. They are quite good. They work very well for a lot of algorithms, of course, classification, regression. Google has been building many of those, so we have some assets there. I will not get into all the details. Some of them, interestingly, for neural networks. As you know, it's quite complicated still these days to explain what happens in a neural network. So that's definitely a space that we are keep investing, bringing them as open source libraries, and more importantly, build them embedded in Vertex. Because by the end of the day, sometimes it's quite tricky. Get yet another library and then implement that and check when the model is trained, what were the outcomes. So what we have is built into the Vertex that I showed you before, some of those libraries. And one of them is, for example, the what if tool, which is quite interesting for analysts. So if you play a little bit with the values, what will be the impact? So that's a pretty common ask that you can also leverage there. So that's in a nutshell. We're going to keep investing on responsible AI as well, but we're trying to get the best of both worlds, bringing it to the product and using what is the standard on the open source world there. And as you know, every month almost there is something new out there to check, but bringing explainability as a key feature is very important for us. OK, last part. I just want to show you a few of the things that I think might be interesting for you. And when I say interesting for you, is not to convince you that it is amazing. I can, of course, say that, but I'll be biased. But I think they work to check and try out. And there is nothing right or wrong in trying something. If it doesn't work, you don't use it, right? Once more, we are in the cloud. It's a commodity model. So we just try things we don't use or doesn't bring value. We just don't use them anymore. So one of them is a class of, well, it's a process. It's called NAS, Neural Architecture Search. Anyone heard about that? One person, of course. Okay, that's interesting. A very easy way to talk about it is using AI to build AI, right? So basically what it does behind the scenes, it creates different topologies of neural networks behind the scenes and hyperparameters and tries to have a better fit, okay? It can be used, of course, in a lot of use cases. I just want to show you a few of them. One of them is in autonomous systems, which I'll show you in a second. I've seen people using it a bit also in data augmentation and also in simulations. Basically, when you have a lot of data points and you want to see how different model topologies can perform better, which can be quite complex, that tries to do that for you automatically. Here we have an example. It's, of course, a company of Google, Waymo, the self-driving cars. And you just have an example here how a machine learning specialist managed to improve the networks up to some level, and then using the NAS got to next level. Once more, it's all about trying out. It depends on your business problem, depends on the data you have available, but quite easily in Vertex you can see how NAS performs in your problem, especially if you have a very large and complex process. And it uses, of course, behind the scene GPUs and a lot of those capabilities. Another one that I'm sure you familiarize in general is, of course, hyperparameter tuning. That's how you make things getting better and better. So there was a paper some years ago that described Visual, which is a solution, initially a paper, but there is also a solution for that to do hyperparameter tuning. So basically trying to get your models better. It's actually used at very, very large scale at Google in different of the problems that I showed you in the beginning. And then what we've done, we just brought it into Vertex. Once more, if you bring in your data, training your models, optionally, you might want to try it with Visual and see what happens there. It's also used behind the scenes when you do AutoML and all those things that I mentioned to you in the beginning. TabNet. Who knows about TabNet? Cool. Yesterday, someone was here presenting that they were using TabNet, so it's quite interesting. It's an algorithm that was published, I think it's there 3 years ago. Very interesting results. It combines two things. One of them is, of course, using on tabular data. So when you're doing, I don't know, for example, forecasting, I think it performs quite well in many use cases. But also tries to not just improve accuracy versus other ones, but to bring the best of two worlds, back to explainability. So it uses neural networks behind the scenes, but it tries to bring the explainability as if it was a decision tree. So that's a quite good one to check out. The paper has been there, code as well. It's been used actually in a lot of Kaggle competitions to outperform other systems. I think it's very worth if you're working with problems with tabular data. Okay, we are just on the end of the time. So just as a recap, I could talk about a lot of AI solutions that I think will be worth. I really try to focus on two sides of the world, especially for you that are data scientists, some data engineers, which is really what's worth to check in Google Cloud Platform. I think Vertex AI is probably the one that is more interesting and relevant for you. As we talked about in the beginning, it's a fully managed service, and this is really important. You just, with a few clicks, you provision the service, and you can start to use it, either the notebooks or training the models, deploying all the things that we've seen. It's really a fully managed service, so you don't need to take care about what's behind the scenes. So think about it as platform as a service that you can get out of the box. Then I've shown you just few of the things that I think they are quite interesting, like some of those algorithms. I talk about a little bit about how you can use GPU capacity, TPU. That's very efficient for cost performance when you're trying to train a large language model, for example. And then I didn't talk about today because I'm sure you all fell asleep. Sorry to say that. If I'll talk about security and all those details, but those details are extremely important. So they are built into the platform. So either from security, key management, all the ones that you would expect in enterprise-grade platform, they are just out of there. That's why a lot of large companies and also startups use that in production because they know they can rely on those capabilities. I'll leave a few links there. Probably the 3 most interesting ones, I think, is the AI blog. So if you get one thing out of this talk, aside from, of course, try to use Vertex if you want, is check our AI blog. There's a lot of nice posts there. DeepMind is also doing amazing things, not just the AlphaGo. There's been a lot of progress, for example, with reinforcement learning for other kinds of games. And the last one is the fraud finder example that I showed you. So that's the workshop that we run here with my colleagues. You can go there, see the code. You can actually provision it from scratch and play a little bit with that, which is the interesting part. With that being said, I really appreciate your time. Feel free to connect with me on LinkedIn if you have any other questions. I'll be also around after the talk if you want to discuss other topics. But a pleasure, and thanks for your time. Attention.
Thank you, Tiago. So we have time for questions, but keep in mind that lunch is after this. So if you want, we can continue with questions, or we can move to the lunch, whatever you want. Questions it is.
With the NAS, how do you see applications in the autonomous driving if you are using AI, which is black box, to advance another AI, which is also black box? So I'm thinking in the terms of explainability connected with the safety.
Yes, that's a great question that I get very often. So, as I said, it's a very fast-moving space, and we do our best effort to try to open source and share as much as possible. On the other side, sometimes it's a trade-off. So some things are really competitive advantage, and these days you can use them still slightly as a black box. So we try to find the best of both worlds. In my experience, and I worked close with a lot of autonomous driving in the past, you always want to, of course, prioritize, as I said, for safety, model explanation, that's very important, but also keep trying what's out there new, because it's very important for your models. So it's a combination, and we are definitely evolving there and publishing and giving explainability as much as possible.
Okay, thank you.
Thank you.
Do we have more questions?
About the feature store. So you mentioned how important it is. Do you guys have any statistics about how many features actually can get used or reused by different people? Like, do you actually get sharing, and do you have any results?
It's a great question. I don't have in my mind direct statistics. I can tell what I've seen in customers. Don't take them as official statistics from anywhere. So, for example, I think the case of the fraud finder, if not mistaken, and the code is out there, so you can double check. I think we start with probably 10, 20 features, and you get up to 40. In customers I've seen, in similar tabular use cases, you get up to 80 to 100 features in the feature store. That's what I've seen. I've seen things more massive, but that's more or less the average I've seen from some use cases. Of course, it depends what you're doing.
Thanks.
But it's not to store 3 or 5 features, let's put it that way.
Any other question? If not, thank you, Tiago.
Thank you very much. My pleasure.